632. It's called More Elimination. So we talked about elimination a little bit last week on Thursday and Friday. It's where you take your system of equations and you see if you can have opposite coefficients. You want one of your variables to eliminate, to be gone, right? And so most of the ones that we saw last week, we already had opposite coefficients. So today's lesson, they're going to give you two equations, and you're going to either multiply one of the equations by something to get those opposite coefficients, or in some cases you might have to multiply both of your equations by something to get those opposite coefficients. Uh-oh. All right. So we're going to answer the question, how can I eliminate a variable? Same question we've been looking at. Question number 90 says dragonflies and fairies. Phoebe was helping her mom buy gifts for her little sister's birthday. There were 11 friends attending the party. Dragonfly wings for the boys cost $1, while fairy wings for the girls cost $2. Phoebe's mom spent $18 on the gifts. How many dragonfly wings and fairy wings did Phoebe's mom purchase? All right. So we're going to use the variables D for dragonflies and F for fairies. Okay. So the dragonflies were how much? $1. So I put 1D. Do I have to write the 1? No, you can just put D if you want to. And then the fairy wings were $2. And the mom spent $18 total. Okay. So that gets you the one equation, and that one's kind of obvious with the way the problem's worded. The other one's not as obvious. Does anybody think they know what the other equation might be? There's one more number in there. What is it? 11. What does 11 represent? 11. How many people are going, which is like boys and girls, but we're already calling them D and F, right? So we're just going to say some number D plus some number F is going to be equal to 11. We're not sure how many dragonflies and how many fairies, but we know altogether there's 11. Okay. So here's our two equations, and we want to eliminate a variable. So we're going to take this first equation and multiply everything in it by -1. So write that down. We're going to multiply everything in that equation by -1. That's going to give us opposite coefficients on our D's so that they're going to eliminate. So here's what the equation looks like. It's going to be -1D minus 2F equals -18. Notice that it just took all of these terms and made everything the opposite sign. Positive to negative, positive to negative, positive to negative. And then just make sure everything's lined up. Your D's are lined up, your F's are lined up, your numeric terms lined up, even those equal signs. If all your like terms are together, then it's going to be easy to eliminate something. So what's going to eliminate? The D's, right? Because we have a 1D and a -1D. Those are opposites. They're going to eliminate. That leaves us with our F. What is 1F minus 2F? -1. Yes. That gets us -1F. And then what is 11 minus 18? Negative what? 7. Did you say 17 or 7? 7. Okay. Gotcha. So we've got a -F equals -7, so we just need to make them both positive. So I divided both sides by -1, which makes F equal to 7. So we have 7 fairy wings. Think about the one equation right here that said 1D plus 1F equals 11. So how many ever fairy wings we had, we're going to have how many more to get to 11? So if we have 7 fairy wings, how many dragonflies do we need? 4. So algebraically, it looks like this. You're going to go 2 times 7 is -14. 18 minus 14, you're going to get 4. a lot of you can see that in your head. 7 plus 4 is going to get you to that 11. Okay? So final answer, 7 fairy wings, 4 dragonfly wings. Okay? Question number 91 says, Rachel is trying to solve this system. 2x plus y equals 10. 3x minus 2y equals negative 1. All right, if we try and combine these, what happens? We've got 2x plus 3x, which is 5x. We've got y minus 2y, which is negative y. And then if we add the 10 plus 1, we get 11. Is that what we wanted to happen? No, what did we want to happen? We want the whole name of the process is called elimination. Did anything eliminate? Nope. Okay, so combine these equations. What happened? We're going to say no variable was eliminated. Problem, right? So that's what happens when you don't multiply one or both of your equations by something. Okay, so part B says, is 2x plus y equals 10 equivalent to 4x plus 2y equals 20? That is, do they have the same solutions? Are their graphs the same? Justify your conclusion. Be ready to share your reasoning with the class. So who knows if 2x plus y equals 10 is equivalent to 4x plus 2y equals 20? Raise your hand if you have a strong feeling, yes or no. Maybe? Dustin?
Well, 2x plus 1 is half of 4x plus 2y.
Okay, so this one is half of this one. Okay? Could we turn it around and say that this one is twice that one? Okay, that. So half or twice. Okay. Let's see. We're going to say yes, they are equivalent equations because they will have the same solutions. You could also say that either what Destin said, that the first equation is half of the second one, or what I said, the second one is twice the first one. Okay. Part C says, can 4x plus 2y equals 20 be used instead of the 2x plus y equals 10 to help solve the solution? Yes, obviously we need it to, right? If so, solve that system. If not, brainstorm another way to eliminate the variables. So we're going to take that 4x plus 2y equals 20. We're going to combine it with the 3x minus 2y equals 1. And now we're going to be able to eliminate which variable, x or y? Y. The y's have opposite coefficients. We have positive 2y and we have negative 2y. So that term's the one that's going to eliminate. And let's combine what's left. What is 4x plus 3x? It's our 7x. And what is 20 plus 1? 21. Is 21 divisible by 7? Yes, we like that. Okay. So we're going to take both sides. We're going to divide by 7. How many times does 7 go into 21? 3 times. So our x variable is 3. Now we need to solve for the other variable y. So we're going to plug it back in. Let's see which one I plugged it in for. Looks like I plugged it into the 2x plus y equals 10. So I'm going to plug in the 3. I've got 2 times 3, which is 6. Subtract 6, so we get 4. We've got our x and y variables, so we're going to write it as an ordered pair. X comes first alphabetically, so we're going to write the 3, then the 4. Okay. Part D says, why was the top equation changed? Would the elimination method have worked if the bottom equation was multiplied by 2? Test this idea. Okay. So to create opposite, okay, what the top equation was changed to create opposite coefficients. If we try to multiply the second equation by 2, we get 6x minus 4y equals 2, and we do not have any opposite coefficients. These aren't opposite, and guess what? Nothing will be eliminated if we try to combine those together. Okay, we still have an X, we still have a Y, so that's definitely not elimination. Okay, so sometimes you're going to have to multiply by something, or both, one equation by something, or both equations by something. All right, I'm going to move this up. You'll see it in just a second if you're still writing, okay? There it is. All right, moving on to question 92. It says there are 21 animals on Farmer Cole's farm, all sheep and chickens. Okay, if the animals have a total of 56 legs, how many of each type of animal live on his farm? Write a system of equations and use the elimination method to solve it. Be sure to check your answers. How many of you have ever been to a farm before? No? Like even just visited, right? Okay, so how many of you know how many legs a chicken has? 2, right? Even if you've eaten the chicken from the store, they come with how many legs? 2. Yeah, they come with 2 legs. Okay, most of you probably haven't eaten sheep, but if you've seen a sheep, yeah, it's not a common thing to eat, but people do. Lamb, I've had lamb, yeah. Okay, how many legs do sheep have? 4 legs, right? Okay, so if there's 56, so let's say 56, yeah, 56 legs total, that's going to be one of our equations. All right, so we're going to let X represent our sheep, Y represent our chickens, okay? And we're going to write 2 equations. So one of them has to do with their legs. So this is the one that's there's legs. So sheep, you all told me, have 4 legs. So we're going to say 4x. And then you told me that chickens have 2 legs. So we're going to say 2y. And all together means to put a what sign? Equal sign. All together, they have 56 legs. Okay? So that's one of our equations, and that's the obvious equation. The other equation has to do with the other number that's there that isn't as obvious. See the extra number? The 21. There are 21 animals. Nothing about legs or how much they weigh or anything like that, just 21. So we know some of them are chickens and some of them are sheep, but we don't know how many of each. So we just say X. Some of them are X, some of them are Y. Altogether, there's 21. Okay? All right, so we're going to solve the system. So I'm going to multiply equation 1 by -4. Why did I do that? It's going to get our opposites. If I look over at equation number 2, I've got 4x, and right here I've just got 1x. So to get to -4x, I'm going to multiply by -4. What if you multiplied by 4 first? Just 4, not -4, but 4. Could you go back and then multiply by -1 again? Sure, you could kind of do it in 2 steps if you wanted to, but multiplying it by -4 is faster, okay? So here's what happens when you multiply by -4. You get -4x. This becomes -4y. And then -4 times 21 is -84. Now you have opposite coefficients. Your x's are opposites. They're going to eliminate. That's what we want to happen. So we're going to combine what's left. So we have a -4 plus a 2y. What does that combine to get? -2y. And -84 plus 56. Might need a calculator for that one. Can anybody do that one? I got -28. Yes, yes. Okay, watch your signs on those. Because now you have a negative and a negative. If both sides are negative, you should divide by a negative. Divide by what? -2. Okay, so divide both sides by negative. That means you're going to have positive 14 chickens. Can you have -14 chickens? All right, so we've got our chickens. Now what do we need to find?